Hi everyone, welcome to the episode 4 of SQL 50 challenge in Leetcode. So those of you who have been following the series, you know that we have solved I think till 32 of the problems. Let's jump into the first problem for today. Okay, so the first question that we have for today is table logs, and we have ID and number. ID is integer, num is varchar, and ID is the primary key. It's an auto increment column. Okay. Find all numbers that appears at least 3 times consecutively. Okay. Input 1, 2, 3 is the ID. Okay. ID is basically row number, like a index column. Okay. And num is 1, 1, 1, 2, 1, 2, 2. Okay. Okay. I can take lead lag here. If lead is same, then okay. Do I? No. Do I do a row number or rank? No, ID is basically working as a row number itself. I can do one thing. So see, it's 3 or greater, right? So that means anyone in the middle for let's say 3, at least 3 consecutive numbers. Lead also will be the same number, lag also will be lag also will be the same number, lead also will be the same number. So we can take that way for any number, like any number group, if the lead and lag is same with the number, then we can safely take that particular number and count of IDs of that number. Let's do, excuse me, let's take that. Why don't we do something like select, and we use lead lag in where? We cannot, I think. Lead lag is a window function that cannot be used in where. We can only use it in group by. So let's create a CT then. So we'll do a select ID comma num. Then we'll have lag of num. Case when. So we need num. No, let's keep it like this. Case when lag of num equals to num. Oh, lag of num over, sorry. Lag of num comma 1 over partition by nothing. Order by ID. No, partition by number. No, if partition by number, then it will be difficult because 1 will also be part of this. No, we don't want that. We just need order by. Order by ID equals to num. And num equals to lead of the same thing. Lead of the same thing. Then 1, else 0, and as flag column from logs. That's it. So what did we do? We basically created another column. So anytime, so we're just considering the middlemost pieces of the consecutive numbers here. So any consecutive numbers sequence or consecutive number sequence which has more than 3 or more than equals to 3 consecutive numbers, they will have at least one middle number which will have the same number in the lead as well as the same number in the lag, like the other way around. Same number in the lag and same number in the lead. Let's say if there was 2 numbers repeating, like let's say 2, 2. So there's no middle number sequence. So 2, this 2 has another 2 in a lag, but does not have another 2 in lead. So that's why this will not work, and only this particular condition will satisfy. And we'll just pick out select ID, comma, no, we don't need ID, right? We just need count of wherever this is 1, basically, so from city where flag equals to 1, wherever flag is 1, I'll just take that particular ID, num, distinct of num, where flag equals to 1. Yeah, I think this should work as consecutive nums, right? Yeah. So anytime this is 1, so here this will be 1, so I'll just pick out that particular number. And that's it. That's all I need. Let's just run this. I think this will work. Yeah, this is accepted. Yeah, this is accepted. Okay, not beating a lot of the traffic here, but I think this is a good enough solution. We're just creating one extra column. Other than that, what we could have done is, I think we could have joined the table just to make sure how many joins are happening, if those are consecutive or not, based on, let's say, ID equals to ID plus 1, and if the number is equals to number or not. I think that way we could have joined and then counted the numbers. That's fine. I think this is also a good enough query. Okay, so let's move on to the next question. We have product price at a given date. Product ID, new price and change date. Didn't we do this? No, we didn't do this. Okay. So product ID, new price and change date. Okay, in the same column basically. Product ID is 1, 1. No, we did this. But okay, fine. Product ID and price. So what do we need? Write a solution to find the prices of all products on 2019 8/16. Okay. All products on this particular date. Assume the price of all products before any change is 10. Oh, yeah, I think I have faced this particular question also in some previous interviews. Should have done lead code. I did solve it though. Not flexing. Okay, let's move on. So product ID, new price, and changed it. Let's see if I can solve it now. So basically the logic that I'm thinking that will be there is that particular date has been provided at this date, what is the price of each of the product? So any product whose price is basically changed before this, immediately before this, that's the number, that's the new price that we will take. So 2019 8/16 is a number, so 35 should be the new price, right? And then product ID for 2, 50 is the number. Yes. And then for 3, price, 3 has no mention before like 8/16 altogether. So then that's why this will be null. Okay. So, okay, what I'm thinking is basically we need that as a static date. We'll get the product ID and the price. We can do a case when case when the change date is less than equals to 16, then this is 1, otherwise 0. So we'll just pick 1, and we can take distinct product IDs also separately. Okay. And then we'll just match up the prices. Okay, I'm thinking about a way. Let's solve it with me. Hopefully this will give the result. Okay, so what I'll do essentially is that I'll create another column, product ID, comma, new price. Change date is this. Hmm. So basically, I'll create a rank function here because I need the latest one, right? So I'll give a rank to over partition by So again, so from products where change date greater than equals to, no, less than equals to 2019-0816, right? So that is the case. Rank over part, so those are the only columns that we are filtering out. So we're not filtering out this altogether, even this, only these many. And within that, we are ranking over partition by product ID. Yeah, because rank is a function, rank is a column that you have to create to filter out. You cannot do it on the go. At least in MySQL or MS SQL, if you are doing it in Snowflake. So there's a capability there inbuilt. You can just directly use the column that you're creating right now for filtering, but we do not have that capability in MySQL or SQL Server. Okay, so partition by product ID ordered by, we need the change date DESC, right? Because DESC is the one, we need the latest one as rank, let's say. Okay, so a rank one, rank product. Okay, so from products where change is before this, and we need another piece, that is we need to join with all the product IDs. So product ID, there needs to be a distinct or product ID, that will be the left join, and then we'll need the product ID and new price from here. Okay, so let's do this. We'll do select product ID. We'll probably do a dot product ID because A will be the left table, comma. We will need the price. So it's a new price as price. No, I'll have to create case when no, I don't have to do a case when. I can do a qualis here. I can do a qualis function. So anytime there's a null, so I'll just take the new price. If the new price is null for some products, let's say the product number 3 in here, which has a change date after 816. So that will just take 10 as the number. As price from, we'll take we will create another table here. So that is basically select distinct product ID from products. So this is your table A, left join, CTE B on A dot product ID equals to B dot product ID. Yeah. Where B dot rank equals to 1. Right? So we are joining based on product ID. Yes, sure, because that's the only column that we have in the table A. And then after that, we're just taking only the rank ones and picking their new price. Right? Qualis. So this does make, yeah, make sense to me. Let's check. Rank in where clause, unknown columns, B dot rank, CTE, is a CTE? Yes, oh, rank product, sorry. Rank product. Wrong answer. Okay, what's wrong here? Product and price. We need 3 as 10. Yeah, we should, right? So product, distinct product ID. Distinct product ID should have 1, 2, 3. And we will get A dot product ID. Qualis new price. New price is from B. Of course. If the product ID is this, and left join, we are just joining this with CTE based on product ID itself, A dot product ID, B dot product ID. The new price is wherever the change date is less than equals to this, and we have taken only the rank product equals to 1. That's the new price. then it should be 10. And the product ID also should be 3. Why? Mm, CT, right? Yeah, okay. It's fine. B rank product is 1. Oh, okay. After join, got it. After join, I'm filtering out rank product equals to 1. That's where 3 is getting filtered out. Because after join, where is happening, right? Hmm. We need null or b dot rank product is null. Yeah, I think this should work. Sorry, I didn't check the order of execution all this time. We don't need 3 prices. I think this is the case. We took 3 column. Yeah, don't need it. Just new price or price. Price. Let's submit this. Or do I need just 10? It's passed, but it's only okay. Let's submit once again and check. Okay, so good enough. I think that was the case. We have to add b dot rank product is null. I missed that and I was thinking, okay, what did I do? What is happening here? Okay, so always remember order of execution, guys. Think. Okay, let's move to the next question. So basically, last person to board the bus is that person ID, person name, weight, and turn. Okay, so person ID is unique values. Let's go to the input table. So person ID is there, then person name, weight, and their turn. So John Cena is the one. So what do I need to provide? There's a queue of people waiting to board the bus. However, the bus has a weight limit of 1,000 kilos. Write a solution to find the person name, the last person that can fit on the bus without exceeding the weight limit. Acha, okay, got it. So last one would be 250, 350, 400, and 200. So this is a cumulative sum, clearly. Total weight is around 1,000. So John Cena is the last one. Whenever it's exceeding 1,000, so that's somewhere we are stopping. Got it. That makes sense. So we have to do a cumulative sum for sure. And let's say if the cumulative sum, so ideally again, I believe a person weighing 250 kilos would be rare. If I actually give correct kilograms, it might even be that the weight limit does not even come in place, like does not even come at the end of the cumulative sum. It can be always lesser than 1,000. And if it is, let's say in case lesser than 1,000, then we will just check the person waiting at the last turn. So last turn would be 6, right? And it's going at ascending order, I'm guessing. Last person to board. Okay, got it. So what I will do essentially is then I will have person ID. Since I only need the person name, I think this is fine. And we would have to go in the order of turn, not by person ID. So that's not an issue. So I will go by turn and keep on adding up the weights. And whenever the weights is more than 1,000, that's like just before that is where I stop. Okay, so essentially there'll be two cases. One is where your weight is greater than 1,000, and another one is when your weight is less than 1,000, but this is your max turn. So you'll take that particular person. Though, so what I will do is basically I'll create a CTE here. What I can do is I can take the person name and then I can take the weight and I can take the uh, cumulative weight. So, right, sum of weight over uh, order by turn, ASC, as cum weight, let's say cumulative weight, right? And we need to take the turn as well. So that's done. So from, we will take this from, this is from the Q table. And then at the end, what will we do? We will only select the person name when either the weight is this, or shouldn't be using if condition here. So the way I'm thinking about this is, let's say if the cumulative weight is uh, oh, actually we can create a flag here itself. I think if I do a case when sum of this is, let's say, greater than 1000, no, I think we'll have to take the maximum turn where weight is less than equals to 1000. So, okay, let's do this as cum weight. Then we will take this where select person name from CTE, where either, so where let's say turn equals to select turn, so max turn from CTE where cum weight is less than equals to 1000, right? So that's the one that we will take. Yeah, I think this should do. This should be fine because anytime it is less than 1000, let's say even if I traverse the whole table and even at the end of the cumulative sum it is not 1000, then also it will pick out the person name who has the max turn. And let's say if someone where cum weight is actually less than 1000 in somewhere middle of the table or middle of the range, that's also a portion, or that's also a piece of section where this code should run perfectly. So let's just do this. I think this should run. Let's see. Okay, you have an error as cum weight. Oh, sorry. I have still included the case when it's not needed. And this is a cumulative sum. This is a window function, so we do not need group by. Again, just reiterating. Let's see. This is accepted. Wow, great. Okay, cool. Then we should move on to the next question. I think anytime we are asking to provide, the latest ranked or last uh, person who has the highest weight, highest rank, something like this, that's where I think subquery should go just fine. We don't need to think about a more complicated uh, operations like joins or, making multiple CTEs here. So this should work fine. This looks easier to read, and I think that just works above all, believe me. So moving to the next question, we have account ID and income. So account ID is the primary key, and then we have number of bank accounts for each salary category. Okay, fine. So we have account ID and income. So all the salaries which are strictly less than $20,000, that's low, and anything between 20 to 50, that's inclusive range. Okay, that's average, and anything beyond 50 is high salary. Okay, so we have to create the categories based on the salary or income and then count the account IDs. Should be straightforward. Let's see. Okay. Mhm. Case when income less than e 20,000, then low salary. When income between 20,000 and 50,000, then average salary. When income basically is greater than 50,000, then high salary, right? So that's what we need. And as say category. comma, count of account ID, right? From accounts group by this whole thing. Sorry. No, I don't need this. End is fine. Category and accounts count. Okay, so if this is a wrong answer, so basically what do they need? They need category to be in lower case, that's fine. And average salary should be 0. I think average salary is not even here, 2250. Got it. But we have to create it some way. So maybe we'll create a base table and then left join that particular table with this one. Yeah, let's do that. Okay. So let's create a base table. So base table would be somewhere like we can just create something like, let's say, low salary. Yes, low salary as, say, category, right? Union. So because in SQL we cannot put a list of numbers or list of uh, categorical values in particular one column. Rather, we have to uh, create all the separate hard-coded values that we have to put within the table separately and then union it with the separate portions of the data. So that let's say I want to create a list of ABC in SQL. So rather than creating ABC in the same line or in the same command, we have to use, let's say, select A as category, union select B as category, and then let's say select C as category, and so on and so forth. Depending on how many values that you actually need to input in your base table. So since we are hard coding these and these are like constant values, there is no other way for in SQL to, like, you can of course always create a separate table, but I think that's more of a hassle right now since these are online platforms and you do not have a dedicated space to create a table. So these are some temp tables in the data manipulation part of SQL itself, which you can utilize, right? Okay. So now moving to, let's say this will be average salary, right? Let's just copy this. Okay, I'll do that. Yeah. Union is fine. So this is a particular table. So I can just directly join this, like select count, right? So income is this, average salary, high salary, this, accounts count, and yep, you just directly take it. I think let's take category. Let's take A dot category, comma. Since we have to inform that anytime this is null, we have to put 0. So let's just do that, comma 0. So what am I doing here? So basically I'm creating a separate table, then I'm using that particular table as my left table, and then we will join it with the below table. You will understand in 1 minute itself when I complete the code. So here in the second table, what we have taken the actual table and data, and based on the data, we have calculated category and counted the total income as well. Sorry, counted the total number of account IDs as well. But here we don't need all of that. So here we just need, let's say, from this is a table, let's say A, and left join this on B on, let's say, A dot category equals to B dot category. That's it, and that's all I need. I think A dot category and Perl is accounts count. Accounts count is only there in B. So if you provide a particular table name, great. If not, that is also great. So by B, we'll judge you for that. Okay, so accounts count and then category. Let's keep it too small because I think this platform is even picking on if your name of the column is lowercase or uppercase. So let's not take a chance and see where are we. It's accepted. Okay, submit and check. Okay, this is also accepted. So basically, our thought process is correct. We could have done another piece also here, like we could have created a CT, then joined it with each other, and then rather than taking like doing the join together at one step, we could have done it at CT level as well. That could have been a little more readable, but I think this is also a very good solution. So cool, let's move on. Okay, so employees whose manager left the company. Okay, so we have employee ID, name, manager ID, and salary. Okay, is the primary key for this table, contains information of the employees, their salary, and the ID of the manager. Find the ID of the employees whose salary is strictly less than 30,000. Okay, and whose manager left the company. When a manager leaves, their information is deleted from the employees table, but the report still have their manager ID set to the manager that left. Okay. So employee ID, manager ID is null, but 11 basically is not there in the employee ID. Okay, got it. So we have to do a self-join here. We have to find out the manager IDs, which is not in the employee ID. And employees whose salary is strictly less than 30,000. So first pick out the employees whose salary is less than 30,000 and then take their manager. Try to map that manager with the employee IDs. Basically same thing. And then whenever the employee ID on the right table is coming to be null, that's the manager ID that we need. And we do not need any manager ID. I think 12 is an employee who does not have a manager. So basically they are the founders, we can say that. And we need only the people who has been an employee. And they have left the company. Yeah, I think this is fine. We can do that. So let's do it. Let's select the employee. I think we need manager ID, comma. Yeah, we just need the manager ID from employees A, join employees B on A dot. So basically this is the manager and this is the employee. E dot manager ID equals to we have to do a left join, I think. Yeah, because we need all the manager IDs and we need only the employee IDs, which is not there. A dot manager ID, B dot employee ID. Think where. So first of all, A dot salary is less than 30,000, right? 30,000, strictly less than 30,000. Yes. Yeah, because we need only those employees who has less than 30,000 and only their manager ID would be picked up from A. And B dot, B is a table where my employee ID would be ID is null, basically, right? Because only let's say 11, I'm taking 11 as a left table and 11 is trying to be joined with the 11 needs to be joined with the employee IDs here. Okay, so one second. Find the IDs of the employees whose salary is strictly less and whose manager left the company. Acha, okay. We also need the employee ID here, not the. And this is again A dot employee ID. So basically, let's say 11 here. So 11 has the manager, his salary is less than 30,000 and manager ID is 6. 6 will be mapped to all these employee IDs, distinct employee IDs in the table B, which is basically the same table. And since 6 is not present here, and 6 corresponding employee ID from table B would be null, and we'll only pick up those employee IDs. This makes sense to me. Let's just try and run this. We can do a distinct here. Not needed because this is one-to-one. Okay, let's submit and check. Okay, wrong answer. Employee ID. To output is needed is 2 and 14 as well. Okay, let's see. 2 is null. So null is also required. Okay, I've given that to be not null. Okay. Oh, got it. Yeah, and null is not required. I've given that. You have to order by a dot employee ID ASC and my a dot sorry, manager ID is not null, right? Cool. All right. So this was a small one. Let's move to the next one. Exchange seats. So you have ID and student ID is a primary key. Each row of this table indicates the name and the ID of a student. ID sequence always starts from 1, increments continuously. So this is the auto increment column again. Write a solution to swap the seat ID of every 2 consecutive students if the number of student is odd. ID of the last student is not swapped. Okay. 1, 2, 3, 4 or 2, 1, 3, 4, something like that. Doris, Abbott, Green and Emerson, James, and all that. Okay, so swapping. Swapping would be something like, okay, this is 1, 2, 3, 4. So 0, 1, we can take like that. So anything which is odd, that's 1, and else is 0. If that is the case, okay, we can do that. So what I'm thinking is, since it's ID, student and ID and student, so odd IDs would become even, and even IDs would become odd. That's what it is. And okay, so last one will not change. Okay, 1 second. If the max ID is odd, then we are going to keep it. So first of all, I'll do something like this. I will create a separate ID column. So if 1 becomes 2, 2 becomes 1, 3 becomes 4, 4 becomes 3, 5 becomes 6, 6 becomes 5, something like that. This can be done. I think we don't even need to think about the 5 not being changed, because what I'm doing here, I'm creating a separate ID column. This will take a space, extra space, but this can be done in one step. So select ID, no, case when ID 2 equals to, let's say 0, 1, then ID plus 1. Okay. When else ID minus 1 and as, let's say, ID, right? And we take student from seat order by ID, and this will be ASC. Yes, right? So let's run this. Select case when. I think this is fine. Oh, sorry. This is not Python. Select case when ID %2 equals to 1, then ID plus 1, else ID minus 1, and as ID. Let's see. Because IDs will also change. 1, 2, 3, 4, 5. Okay, got it. So if you see the sorting is done, you need the ID separately. What I will do instead here is I will create a separate ID basically. Let's say row number over order by ID. Hmm. 5 becoming 6. Is there another way? If it is a case when, let's say, ID person 2 equals to 1 and ID equals to select max ID. Huh, okay. We can do another piece. Just add a small subquery in the middle. So let's say when this and ID equals to, let's say, select max ID from from seat 10 ID. Keep it ID. Do not change it. When everything else remains same, then ID plus 1. Else ID minus 1. Right. Okay, so let's run this. This is also another way. Submit and check. Accepted, but it's only beating very small percentage. Hmm. Okay, let's do one thing quickly. Let's check the same query in SQL Server. Ideally, maybe even if it does, it will not beat. Okay, beat 36%. Not very bad. I can change a little here and there. The indentation also affects in platform. So, sorry, not run. I would have done a submit. If it improves, great. If not, it's okay. I think this is a good enough solution. Yeah, I did. See, indentation actually makes a lot more impact when you are practicing in an online platform. So if you are looking for, the highest ranked to become a highest ranked individual within the particular challenge that you have accepted. So yeah, feel free to make it as aesthetically enhancing as possible. So okay, so for me it's fine. I'll just move on to the next question. Okay, so the movie rating. This is the new problem. Movie ID and title. ID is the primary key. And title is the name of the movie. User ID and name. User ID is the primary key. Okay, there are two tables. No, three tables. Movies, users, and movie rating. Write a solution to find the name of the user who has rated the greatest number of movies. In case of a tie, return the lexicographically smaller username. Lexicographically as in lengthwise. Find the movie name with the highest average rating in February 2020. In case of a tie, return smaller movie name. Okay, let's see and let's walk through the problem. Movie ID is 123, user ID is 1234. Movie and user, okay, it's already there. Rating. Results would be Daniel and Frozen 2. What? Okay. Daniel and Frozen 2, both in the same column. Okay. We have to union this, but that's fine. That's at the end stage. First, movie and user ID is there. Rating is there. Created at is there. Explain Daniel and Monica have rated 3 movies, Avengers, Frozen, and Joker. And Daniel is smaller. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, lexicographically, I think this is by It starts with D and this starts with M. So we'll have to take the earlier one. In, I think, ascending order, we have to take the first. And then Frozen 2 and Joker have the rating. Again, we have to take F because F is uh, alphabetically lesser in rank compared to J. Got it. Okay. So again, what we'll have to do, title and name. We can take the title and name later as well. First, we'll have to do uh, rated the greatest number of movies. Okay. So take the user ID and take the movie count of movie ID basically. Whosoever has the highest rating, you will map the name and then take out, in case of a tie, you'll just take the name which is appearing first on the table in terms of ranking. So let's just create the first portion of the table. Let's say CT1, let's say users, right? Let's name it as users. So select user ID, comma, count of movie ID, right? Um, we can do, no, first we have to do this only. From movie rating as A, let's say we can join directly with the user table here, users B on, user ID equals to user ID, A dot user ID equals to B dot user ID, sorry. And that's the way you get your, you can do A dot user ID is fine. Okay, so movie rating, and this is your base table. And after that, you have to create a rank based on what is the count of movie ID that you have got. Let's say count movies, right? So we have to create another CTE from here, or you can just do it. This is a small enough table. You can take a subquery as well. Would not make much difference. So select, we will, let's say we will take user ID. No, we need the name as well. So we need the user ID, we need the name, user ID, comma name, and we will only take the name. We will actually do a rank as well. Oh, we have to do 3 CTs because rank has to be there separately. This is a long query. This is what I feel. Because I cannot, since I have to do count at one level, I cannot do ranking at this level itself. I have to do ranking at the another level, and then I'll have to take the first one. Why don't, rather than ranking, since I need only the top one, why don't I take the top directly? Top user ID, top one, name, from directly here. Uh, order by TESC, and we have to take name ASC, right? If I do a select star from, so this will give you directly the, and top one name as, let's say, results, right? So results is fine. So we have to do a union. Let's not do a with here. I don't think we need this. Select results from, let's say A. Let's say first part of the query, right? This will be users. Let's say users is on table, right? Oh, it is okay. User first part, or yeah, you can see that this is first part union. Then we'll do the second part. Second part would be similar thing. It's just that we need, sorry, find the movie name with the highest average rating in February 2020. So we'll be doing a, let's say, select movie ID, average rating from movie rating table, group by movie ID. We have to select the top one. Okay, I can just do a join here itself. Join. This is movies on a dot movie ID equals to b dot movie ID. Movie rating A, sorry, B, and this will be movie ID comma title, and this also will be grouped by movie ID comma title. And that's it. That's all you have, and then you do a highest one, right? Average rating as, let's say, rating. You take out the top one, select title from where, no, top one title, right? Top one title, order by rating DSC. Oh, we have to do a order where as well, where created at is month of February, February 2020. 202002. Okay, so let's say left of created at, comma, 5677 equals to 202002. We can try this. And group by movie ID, title, order by rating DESC, and title ASC. This should be fine. Top one title. Select top one title as results. Select top one title as results. Top one name as results. Select results from these two tables. First part and let's say second part. Okay, let's run this and check. Okay. Order. Order. Okay. Nothing came out. Incorrect syntax near the keyword order. Select top one name as result. Name. Name is fine. Name is what you have. Yeah. Name is there in only one column. Order by count movies. Oh, sorry. This one. Count movies and name ASC. And this would be movie ID and title. Order by rating DESC and title ASC. Okay. Let's try and run it. I did change the count movies part. Is it the same error? Order by. Okay, let's do run it. Debug and run it. Incorrect syntax near. Okay, let's try if there is a. It's fine. This is fine. Okay, left of created at comma 7. Let's try and run this. There's an error with a bracket. Average of rating is something that we have. 102. Where is 102? Okay, let's do something. Let's run this part. Let's do, oh, sorry, commenting. Pull below one. See, where is the issue coming? Okay, this is here only. Select results from. Oh, wait. Yeah, so this is fine again. Okay, let's uncheck this and run. Okay, so this is the wrong one. From select a dot user ID name. Okay, let's do something. Again, let's put this out the way we debug. The wrong answer is fine, but at least something should have come. Right? User ID name count movies. 3, 3, 2, 1. And Daniel would be there because that's what is needed. We just need the select top one name as results from order by count movies and name ASC. Okay, let's just do this one. See. Should be fine, but let's see. Oh, okay. Do I need to give an alias? I think that can be the case. Movies one. Probably. Let's try that because I have not done subquery for a long time. Could be the case. Yeah, okay. So you have to give alias. Daniel and Frozen 2. Okay. Everything is fine. Only we need to provide the aliases. Otherwise, the platforms won't consider the results as a proper one. So here give like, no, let's give this users one. And let's give that as movies one. Okay. Let's run this. Keyword order by. Okay, this worked just fine. Okay, again. Let's do this. Check the first portion. We have checked till this part. Let's check the last part as well. Wrong answer is fine, but should give something. Daniel, yes. Okay, so this is good. Then let's check the last piece. What's the issue here? Okay, let's run it. Okay. Movie ID. Okay, select movie ID. A dot movie ID. A dot movie ID. And title. Sorry. Think this should run now. That was the issue is what I think. Let's see. Oh, here we don't need this too. Select star something like this. Where it should run. Avengers. Why? Should be frozen 2. Okay, average rating as rating. Okay, let's again, sorry, stop this. See what is happening. Because if it's Avengers, means Avengers average rating is high. Three, three, three. Okay, everything is 3. Why? Well, the highest average rating is in February 2020. So let's do February 2020 is this 4, 2, 1. It was Monica, no. Frozen 2. 5 and 2. Okay, we have to do a round, I think, average of rating. A round of 2. I think that way it will be better because otherwise it's rounding off to 3 for everything. And that's where it's difficult. I think average rating will always do this. So let's do something. Let's do sum of rating, right, by count of user ID, right? And let's do it at float level, or let's say decimal point level. And that's where this will make sense. Let's do this. I think this will help rather than directly taking average. Yeah, 3, 3.5 and 3.5. Cool. Okay, that is the case now. Now I think this should run fine. Average in SQL is not a great aggregation method. Frozen 2? Cool. Now you uncomment everything else and you're good to go. Right? So let's run this and check. Accepted. Now submit and see. Wrong answer. Okay, 18 out of 19 test cases have passed. This one is down. Okay, so there's only one movie ID. Title is this, Rebecca. User ID is also Rebecca. Okay. The rating is 5. The result is this. Okay. If it's Rebecca, it needs to be distinct. Okay. Select distinct results. Now this is very weird. Ideally, it shouldn't be the case, but let's see. Because I'm just trying to think of the actual use case where the name of the critic and the name of the expected is Rebecca, and I'm only giving Rebecca. Why I should give both? Let's use this test case and see what I'm getting. So my first part is, if I just, sorry. This should be giving Rebecca as well. Let's see, what is it giving? Sum of rating is 5. No, that's fine. Let's see. No, test case 2. Rebecca. This is only giving Rebecca. Okay. And then the next one is not giving Rebecca. It should. Second one is giving Rebecca correctly. Let's see. Case of test case 2. Count of movie ID. Then what is the problem? Oh, okay. I'm doing union. I have to do union all. That's why it's deduping the outputs. So union basically dedupes the rows so that none of the rows are repeated, whereas union all basically just adds up how many ever rows you have, one on top of each other. Doesn't matter even if those are repeating. I'm not exactly sure why this platform or this particular question needs a repeated name and movie name as well, but okay. If they need it, we'll just provide it. These do not have, at least I don't know, much practical or relevant use cases in real world. If you know, please let me know in the comments below. I'd love to know it. Okay, moving on to the next question. This is restaurant growth. Restaurant growth is customer ID, name, visited on, and amount. So you're the restaurant owner. You want to analyze a possible expansion. You're the restaurant owner. Okay, you have customer ID, name, visited on, and amount. This is customer, and I'm the restaurant owner. Okay. To analyze a possible expansion, there will be at least one customer every day. Compute the moving average of how much customer paid in 7 days window. Current day plus 6 days before. Average amount should be rounded to 2 decimal places. Return the result table order by visited on in ascending order. Okay. So customer ID name, visited on, and amount. Output is visited on, amount, and average amount. Okay. And you need it at customer ID level, right? So John visited twice. So that'll 100 and 130. That's somewhere around okay, wait, one second. Moving average, how much the customer paid in 7 days window. Average amount, 100 and 130 would be 115. Nope. Visited on 17 or 110. Be 1000. Okay, sorry, I need an explanation again. Return the result table ordered by visited on in ascending order. So you are the restaurant owner, you want to analyze a possible expansion, compute the moving average of how much the customer paid in 7 days window. That's fine. So this is not at customer level, this is at day level. Amount 17. 17 is here. 17 amount is 150, but it's 860. Okay. First moving average, I need the explanation. I'm not understanding. So 7, 8, 9, 10 visited on, but there is 1, 2, 3, 4, 5, 6 as well. So it's starting directly from 7 because it's letting go of the first 6. Okay. So you need directly, okay, the total amount 150, 140, 110, and so forth. So this is 290 and this is 400 and let's say this is another 250, 650, 750, 860. Ah, okay. Got it. See the total from 7th. Okay. And you need the average amount as well. Average amount at day level, not at customer level, right? Moving average, how much the customers? The customer, no, I think the framing is wrong. A particular customer is called the customer, but we need every customers who paid in 7-day window. We need the average amount as well as the total amount, right? So first moving average is 1 to 7 has total 860 and 122 by 6. That's yeah. Okay. So we need moving averages, total and average. So let's do select anything. We have the first 6 days, we're letting them go. We just need from 7th day itself. No, that's fine. I'm just thinking, how would I let go of the first 6? Like I'll have to filter those out separately. Okay, first let me just tell you the calculation how to do it. So we will check visited on, yes, sorry. And then we need sum. Sum is sum, we need amount. Amount is sum of amount over. So here we need partition is not needed because customer ID level is not needed anywhere. They just need order by visited on, sorry, on ASC. Then we need rows between 6 preceding and all that. So we need rows between 6 preceding and current row. sorry, preceding and current row, right? Yep, as let's say amount. And the same thing by 7, because I don't think average is again going to show us the rounded number. So let's just take, we can try taking average actually just to see if this will give us anything. This is the average amount, let's say. If not, we can just change it from customer. So that's it. That's all we need. But visited on where, let's say visited on, we need from 7th row onwards. Here it's 1 7. That's always it is not going to be 1 7, right? Another test case can be another date altogether. Let's do a round off of 2. Round of 2. Can do a 1.0 here. And then that's it. 2 is average amount from customer where visited on. I need a rank. No, actually we can just do order by visited on offset, say 1 6, offset 6. We can do something like this, right? Yeah, let's try. I'm not sure if offset function works in SQL Server or not. We can just try it on MySQL. Yeah, this is not going to work. Let's just copy this. Go to MySQL. Limit is anything. We don't care about limit, but this is something. Offset 6 is something that we need. Okay, this is not accepted anywhere. I'll figure this out. Let's just run this query just to check if it is giving the correct result from 7th row onwards or not. Yeah, 860, 102, 22, 86, 120, 20, 121. Why are there two columns? It shouldn't be two columns. Why are there two columns? To 2019, ordered by visited on, right? Are there two? Okay, no, that's fine, but should be summing this up. This is definitely at visited on level. So partition by visited on. Yeah, we need this. I thought it's like each row has separate date, but that is not the case. So we need this. Let's run it. I think everything else should look fine. We just need to figure out a way to top it to only like start it from row 6. Row 7, sorry. What happened? Oh, no, 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 no. Sorry, 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 sorry. Partition by is cannot be there. If it's partition by, then it won't do a cumulative sum. So this is fine, but okay, got it. Let's just do first bring the whole table at visited level, right? On comma amount, sum of amount from customer. Right, and then you select from here, from CT. That's all you need. This should look fine, but then offset. How do I offset? Can I use a rank function here? I'll just take row number on 7 onwards as over, let's say, order by split on AC as RN, right? And then we'll just take order by visit on, yes, but we can just do RN. Showcase 6 onwards. I think we'll have to create another CTE. Let's have RN as well here with CT2 as no, not star. We need visited on amount and average amount from CT2 order by no, where RN greater than equals to 7. Right? Think this should make sense, but let's see. Oh, sorry. Accepted. Let's see the next one. Okay, this is also accepted. Let's just do a quick indentation. If it improves, great. If not, then also fine. We'll just move on. Yep, it did. So indentation is very important here. So we can absolutely take care of that. Now, this is going to be the last of today's problems. Let's check out. So friend requests to who has the most friends. Okay, you have request accepted, requested ID, acceptor ID, and accept date. Okay, write a solution to find the people who have the most friends and the most friends number. Most friends number. Didn't understand. The test cases are generated so that only one person has the most friends. Oh, okay. So there's no case of a tie here. Basically, that's what they are telling. Request accepted table is 1, 1, 2, 3, 2, 3, 3, 4. Okay, ID 3 has the most friends. Sorry. So they've requested and this is accepted. Here is also this is requested. Hmm. The friend of people 1, 2, and 4. So he has 3 friends in total, which is the most number than any others. Got it. Okay. So what we'll have to do is what I'm thinking. First, let's say we can take requester ID, group by requester ID and count of acceptor ID. Do I need a date filter somewhere? No. Okay. So requester ID and acceptor ID, count of that. Again, the same thing, acceptor ID and count of requester ID. Yeah, right. And then we'll do a union of the two. And then we can take the ID and num. I think this should work. Let's do select requester ID. And ideally, what I'm thinking is, let's say acceptor ID. If one has sent a request to 3, 3 cannot again send request to 1, right? So there's no chance of duplication here. So let's just go ahead and do this. So it's select requester ID. Anytime it is if it is not there, if it's unfriended or something, I think unfriend option or the complication is not there in the table. If it was, then we would have had to, let's say, unfriend, and then again, let's say if they have requested back, we would have had to change it that way. But I think this is a simpler version, so let's not go into those complications. Let's just start with requester ID and let's say count of acceptor ID has, let's say, friends or something. Num from request accepted join or union, the same thing. So requester ID as ID. So the exact same thing. We'll just change it to acceptor ID and then do a requester ID, right? As num, and then we need this. We need the select ID comma num from here. Let's say base table order by num DESC. So we can just take top one, right? ID comma num from here. Let's run it and check. Oh, I haven't given group by. Sorry. Group by requester ID. Sorry. A requester, not tor. From, sorry, group by acceptor ID. That's it, as ID, right? Let's run. You have an error. Check the manual. 1. Okay. I think top is not needed. Let's do select limit 1. How about this? Yeah. MySQL has limit and MS SQL Server has top. Okay, wrong. ID is 1 and 2. Okay, let's see. So I have done requester ID and count of acceptor ID. If I do that, let's go step by step. The first one. So requester ID is 1, count is 2, 2 is 1, 3 is 4. Okay. And acceptor ID is 2, 2 has 1, right? And 3 has 2. Oh, yes, I have to do a sum here. What am I doing? So now ID, comma, sum of number, right? ID and sum of number as num. From here, group by ID, order by num DSC, and limit 1. Yeah. This is only counting. I have not done the sum at friend level per se or person level. Wrong answer. 11 out of 12 test cases passed. Okay, let's see. Let's use the use case. What happened? I have returned 10 and 9, but it will be 17 and 10. 17 would be okay. Let's remove limit 1 and check. Run for the case 2. That's fine. 17 has 10. Oh, 17 is not even coming. 17 is 5. Why? Now let's see. 17 has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a clear winner. Why not? Let's see. Acceptor ID as ID and count of requester ID as num from request accepted group by acceptor ID. Okay. Good enough. Requester ID. Then you take the IDs, all the IDs, right? ID, comma, sum. First, I'm doing union. I'm doing union though. Because 17 and 10. Okay, correct. Because 17 has 5 both the time, so it's getting rejected once. That's why it's not coming as 10. This should give the result correctly. No, okay, let's see. Oh, limit 1, but 17 should be there. 17 is not there still. Okay, let's see. 17 is there overall. Yeah, 5 again. Should do union all. Requester ID, acceptor ID, num ID, and then total sum of num group by ID. Order by num DESC. Mhm. 17 should be twice presented. But okay. Should have been solved. Union all should be correct here. Let's do a select star. Let's just do this. Why is it not getting selected? Let's see. 17.5 should come twice in this output. 17.5, 17.5. Yeah, it has come. Then what is the issue? ID and sum of num group by ID. Okay, let's just do this again. ID. Let's run it. Seventeen is 10. Okay. Then what happened? Order by num DESC. 17 is 10. So let's see. Okay, now it's coming. I don't know what happened, but let's see. We need limit 1 and submit. Cool. Okay, so that was it for today. I hope you learned a lot from this whole series. I think there'll be just one other video of this. We will end it with that particular video, and that will be all for this SQL 50 challenge in Leetcode. So keep practicing, and we will meet you in the next one.